Alright guys, this is for lesson 7-9. 7-9 is talking about direct variation. Okay, direct variation is a linear function that can be written as y equals kx. The k has to be a non-zero constant, which is also known as the constant of the variation. Okay, now I know that sounds like a lot of language, so let's talk about what that looks like. If I were to give you a set of data, something like this, where I had age and then I had length, maybe talking about a growth chart here, okay? So for every age this person went up, they grew so many inches. So when they were 3, they were 22 inches tall. When they were 6, they were 24 inches. When they were 9, they were 25 inches. And when they were 12, they were 27 inches. So what we're going to do here is first make a graph. So let me go ahead and pull up, well, you know what, I'll just probably faster if I just make my own graph here. Of course, you guys are using graph paper and rulers. Mine's kind of shabby here. Okay, so I'm going to go 3, 6, 9, 12. This being the ages going across the bottom here. And going across the top here, I notice all of my answers are in the 20s. So I'm going to start with 20 and just go like that. 20, 22, 24, 26, 28. All right. So now let's graph my points. I'm going to go over 3 to 22. I'm going to go over 6 to 24. 9 to 25, which should just be right below that 26 there. And 12 to 27, again being right below that 28. Now, of course, you can draw a line here, be a straight line, okay? But if I had graph paper, it actually wouldn't look that perfect. This graph does not line up. If you're doing this on graph paper, you'll notice this one actually, let me see if I can fix this a little bit. These last 2 points I plotted are not exact. All right. Okay. So if I were to have a straight line, you're going to see that they would not line up, okay? If that happens, this is not a direct variation. Another way you can do it is called method 2, which is comparing the ratios. So let's say I picked 22 over 3. Remember, it's the change of y to x, kind of like finding slope. Versus, I'm picking the first and the last one here, 27 to 12, okay? Now, if you do a cross multiply, which this would be 3 times 27, and this here would be 22 times 12. This one up here, I get 81. This one here, I get 264. Do you see how these are not the same? Remember, a ratio has to be the same on both sides of the equal sign. So 81 does not equal 264, making this not a direct variation. These are not equivalent ratios. Okay? So let's look at another one. What if I had this value? Looking at maybe time and distance. So we're going to talk about a train traveling here. So we have time and distance. Okay, so let's say this is in minutes. So 10 minutes, this travels 25 miles. In 20 minutes, it travels 50 miles. In 30 minutes, travels 75. And again, 40 in 100. Okay, again, you could graph this out, and when you graph this out, you would notice that it does create a straight line, And since I'm not using any graph paper here, it's kind of hard for me to show you that. So I'm going to do method 2, which is to line up them as ratios. This time I'm going to line them all up. So these should equal all the way down the board here. Okay, writing these all out. Always putting the y over x, or just flipping them upside down, whichever is easier for you to remember. If I were to multiply, let's say these two together and these two together, which means I would have 10 times 50, and I would have 25 times 20, I would get 500 each time. Now I can stop right there, because once that happens, then I know for sure the ratio is constant. So it is constant. Okay? And that means the relationship does have a direct variation. Alright. So let's also try this one here. Okay, what if I had a pen that worked? Would be nice. Alright, catch up with me, guy. Here we go. What if I had 5 over 20 equals 3 over 30? Is this going to give me an equivalent constant ratio? So the first thing I'm going to do is 20 times 3, which is going to give me 60. And then 5 times 30, which is going to give me 150. Are these the same thing? Does 60 equal 150? No, it does not. So these are not equivalent. It is not a direct variation. Okay? What if we had this setup? Let's try it as two different numbers. If I said compare these ratios. So we have 1 over 8 equals 2 over 16. Okay, so if I'm going to multiply these out, I'm going to go 2 times 8, which is 16. And then 1 times 16 is 16. Do you see how they're both the same? 16 equals 16. The answer is yes, they are equivalent, and yes, they are constant, and yes, they are direct variation. Gets yeses all the way down the board. Alright guys, I hope that helped you for your homework tonight.